Alright, back with part 3 of my review, or whatever you want to call it, my technical explanation, my overview of the Yamaha A-S1100. And what I've done is I've already removed the top cover and the two wood side panels. There's the hardware. And so I have it exposed, but first, before we look inside, there's the front. So basically there are these two side panels, have two screws, they lift up, one on the other side, and then the top panel's got like 8-10 screws. It was pretty simple. Alright, so let's start with the back panel. It is, well, first of all, everything is extremely well built, and all of the internal components and the wiring and the way it's put together it's all super high quality. I'm happy with everything. We'll get into the inside in a minute, but so too is the back panel. Very impressive. You know, all gold plated connectors. Speaker lugs are just it's kind of a unique design. They have this kind of triangulated area to grip. Makes it really easy to grip. High quality, instills confidence. Got some rather large holes in them for the biggest speaker wire you could ever shove in there. And the fronts of them accept banana plugs, banana connectors, which I use. Now, getting close here. So what we have on the back is, starting over on the left side, we've got our inputs for tuner CD line 1, and there's the phono input, and there's the ground attachment, and there's a switch for switching between the moving magnet and moving coil phono preamps. And again, both of those preamps are fully discrete circuitry, no op amps involved. And of course, going between the moving magnet and the moving coil changes the gain. I think moving coil needs a lot more gain, I believe, if I remember. I haven't had a moving coil cartridge maybe ever. I've always had moving magnets, but okay. So there's our line level inputs, and here in this area here we have an input and an output for what would once be, a long time ago, would be a cassette deck. PB stands for playback, and then record is up there, and record is basically outputs a line level signal of whatever source you happen to be listening to. And it's not a variable signal, it's just a line level signal that'll enter into whatever your recording device is, whether it's a taped, cassette deck, reel-to-reel, or CD recorder, or whatever you have. And then that same device plays back through the PB, and that will be selected by line 2 on the front. And then right here we have our preamp outputs and our main amp inputs. And the preamp outputs is just that. It outputs a signal from the preamplifier, and you can drive a separate amp or mono blocks or whatever you want. And main in is simply a preamp in. So if you want to use this integrated amp as just for its power amplifier portion, bypassing all of the preamp stuff, then you have a separate preamp and you plug it into main in, and you select main in on the front panel. Okay. There's our other speaker terminals. Again, this amp doesn't have 4 amplifiers built into it. It's a stereo amp, so you have to be careful hooking up multiple speakers to make sure that if you had 2 sets of 4 ohm speakers and then you ran them A and B, then you'd suddenly be dealing with 2 ohms, and that's not a good thing for most amps. There's one interesting thing. I don't know if you notice what's really strange, or I should say unusual, about this power amp just by looking at this area right here, and I'll tell you at the very end. So up here we have auto sense, auto power standby, and at will. You know, I don't exactly know. I know what it does to me is if I leave the amp on, it'll turn it off after so many hours. In other words, if it's just idling and I forgot to turn it off, it'll automatically turn it off. I believe it automatically turns it on when it senses a signal, but I'm not sure. I haven't done that yet. I go ahead and use that because sometimes I play music and my playlist stops and I leave in hours on end, and I really don't need this thing idling for 8 hours. The nice thing is if you wanted to, the switch is on the top, so if for some reason you didn't want it to accidentally go off, then you could just reach over the top panel and reach down and you know, knowing where the switch is, just hit it the other direction. And then this is for I've never used any of these things on any amps, but I guess there's a trigger, some kind of trigger in to turn the amp on, and there's Yamaha has some remote connectors to it, and I've never used them, so I don't exactly know what they do. Now here's the interesting thing, and there's the power receptacle there, and you'll notice it only has 2 prongs. It doesn't have that third one in the middle, because that third one in the middle is earth ground, and this thing is not earthed. It's not referenced to earth ground. Everything in it is floating, and so that's kind of a unique aspect of this. And not many amps or equipment in general that has this kind of power receptacle goes without the earth grounding, but that's just the nature of this amp. So there we have it. Nothing unusual here, nothing overly fancy. It's very pretty, it's very well built, nicely done, impressive. Now here's the inside. On the front, we're looking at the front right now, and then behind that, we get some kind of pointer here. This thing is not plugged in. So behind this panel here are the VU meters, and that's all the function and control circuitry. You can get a look down there at some of the potentiometers. I don't know if you can see them or not. Right there's right down there are the I believe that's the bass and treble. I'm not even sure because I can't see the front, but interestingly, there's the volume control potentiometer right there, and you can see the motor. You'll see a round motor right there, and it's a motor-driven, basically a motor-driven switch, because the volume control is electronic. It's not a motor-driven potentiometer. It's a motor-driven switch. And I forget how many detents it has. It has a ton of them because it's so sensitive. It varies like a potentiometer, and that controls basically a circuit that changes the resistance. So there's no risk of like in the old receivers with potentiometers, there's no risk of getting that static stuff in there from the carbon flaking off the wipers inside of potentiometers. It's a nice smooth volume control, very, very well done. There is the transformer. It's a beast, it's huge. I guess Yamaha makes their own stuff, or at least they put their name on it. And here's the main power supply. There's little power supplies here and there for some of the other circuitry, but this is the main power supply board for the power amps. 4 large capacitors. They have this little foam thing that's kind of caulked on. I guess it prevents them from vibrating relative to each other. And here is one of the main power boards. There's one on the other side. This is for the left channel, and you can't really see much, and you really can't see the MOSFETs. They're connected to the heatsink through that little gap there. Can't really see anything. So very well done. You can see all the discrete components, and kind of nice in a modern piece of equipment to see real real carbon resistors in there. The old style resistors. But you can see capacitors, resistors, everything is discrete. No integrated circuits anywhere to be found. Kind of nice. There's the other side, the other power board, and you can see right here these orange and black. Okay, these are they're very fat wires. These are the wires that connect from the MOSFETs up to the speakers. And you can see on the speaker connection there's two relays. Those are the speaker relays that connect the speakers, and they're also hooked up to the protection circuitry that will turn them off rather quickly if there was an issue. And those wires are fat. What are they? They are, what do they say on there? They are 14 gauge. Really big. And there they go. Trace them back to the connector. That little white connector down there with the black and red going into it. So those are the main power amp boards, and back here, really well done, nice circuit boards, really high quality. All the connections. I mean, look at these brass lugs right here for internal grounding. And so back here we have that's the microprocessor. There's microprocessor control of the I think the protection circuitry, and perhaps some of the controls. The microprocessor has nothing to do with the power amp other than protection circuitry and monitoring, but nothing in the way of the signal path. All high quality components throughout. Let me turn this amp around and we'll see if we can see anything. I don't know what else we can see on the front, but I don't know if you can see anything down there. It's kind of dark, and so really I won't get into too much detail about this. It's just I just wanted to see the inside, and plus as I mentioned in one of my other videos, I'd like to do a test on this thing to find out how much Class A bias there is before amp switches over to Class AB or what have you. And here's my little test point right there. I'm going to have to squeeze something in there. I can get from those little, there's 3 connectors, but there's 2 of them I need, and that'll give me an insight into the current flowing through I believe it's the source, a little, I don't know if it's the source or the drain. I have to look at the schematic. There's a little 0.1 ohm resistor, and by scoping that resistor, I should get an idea of what the current looks like that's flowing through the MOSFET. It should be a direct depiction of that, and and hooking up to a dummy load and cranking it up, I should be able to see when this thing switches over into Class B. I'm not sure how this is going to work, but again, I can't use an ordinary scope to do that, because these scopes are all referenced to earth ground. Okay, the little ground lead alligator that comes from the probe is earth grounded, and so I cannot be just hooking this up willy-nilly, because nothing inside this amp is referenced to earth. There's no earth ground, period. So I have to take what's called differential measurements, and I think I'm going to use a little battery powered crappy, crummy oscilloscope that I have, but it'll work. And given that it's battery powered, it's not referenced to earth ground, or it's not referenced to anything in the power chain, period. So I should be able to take differential measurements using that. So that's about it. Very impressed, very well constructed, very well built, really nice. And again, doing this whole review just because I love the sound so much of it. I just wanted to, so I love the sound of this amp so much that I just wanted to kind of get an idea how it works and look at its construction. And again, I think this thing is well worth the price. And again, there's interestingly, there's at least two more costly versions of this. The AS2000 or 2100, or I forget, and that's like $900 more. And there's a version of this that's over $6,000, and I forget the AS number of that. But I've pulled all the schematics for all of them, and there's very little difference in the power amps. It's the same, it's the same amplification. So for as far as value goes, you're getting the best value in the AS1100 by far. Okay. See if I can get in any more angles. There's the speaker output relays. Nothing really to see down there. I'm not going to take anything else apart. I don't want to completely disassemble this thing. Another view of the main amplifier boards. I don't know if you can see on the main amp board over there, there's a copper bus bar running down, right down the middle of it. And that bus bar is depicted on the schematic. It carries the high current of the speaker load, and they're using a bus bar because that current is too high to put through a simple trace on a circuit board. So they have a bus bar running down there, and there's multiple, at least 6 taps off that thing for the circuitron, basically. Better view of that power transformer there. There's the caps. What are those caps? 1863 volt, 18,000 microfarad. I can't see. But they're Japanese sourced components. They're not Chinese, as are most of these components in here. Alright. So there you have it, the back and the inside of the AS2100. It's a wire bus running down the edge there. Mostly coming from the microprocessor area right here. So that microprocessor controls all the functions and the various relays, and again the protection circuitry. And I'm just looking around. See, there's all that surface mount stuff there on the microprocessor board. Very tiny resistors. Alright, I could look at stuff like this all day. I just enjoy doing this, but I'll cut this short. But anyway, this is the end of part 3, and if things go well, part 4 will be some measurements that I'll be taking on here with my battery-powered oscilloscope, so I can take differential measurements and not reference to earth ground. Okay, that's all for today. Thanks for watching, and hopefully later on this week I'll be making part 4. Ciao.